Well, now we're dealing with the graphs of polynomials, and we've got to deal with degree, and the degree corresponds to the largest variable, or excuse me, the largest value of an exponent on a variable. So the largest exponent on the variable x is 2, so the degree is 2. The leading term is minus 3x squared. That's the degree-setting term, and correspondingly it's called the leading term. Its position, whether it's first, second, or third, has no bearing. And the leading coefficient is minus 3. That's a coefficient on x squared. The constant term is 4. That is not attached to a variable. And the right-hand behavior will be down. Down because the sign on the leading term is negative, so the right-hand behavior will be down. Let's do another one of these. Well, we have another one of these, and this time the degree is 5 because that's the largest exponent on any of the variables, and the variables are all in the form of x. So 5 is the degree. The leading term is the degree-setting term, and that's 2x to the 5th. The coefficient, or the leading coefficient, is 2. That's the coefficient on x to the 5th. The constant term is 1. That's the term for which, such that there's no variable attached to it. And the right-hand behavior is up because the leading term is positive. Now we're going to graph a polynomial, but first we have to find or determine the zeros. So we'll set each factor equal to 0 and solve. And we can do that in our head by inspection. So here's 3 factors: x, the factor x plus 2, that quantity squared, and the factor x minus 3. What value of x will take x to 0? Well, 0 will. And what's the exponent on x? It's 1, so the multiplicity is 1. What value of x will take this expression to 0? Negative 2 will. So negative 2 is a 0. And what's the exponent on this expression? It's 2, so the multiplicity is 2. And finally, what value of x will take this factor to 0? And that's 3. So 3 is a 0. And the exponent on that expression is 1. So the multiplicity is 1. To find the degree of this polynomial, were we to multiply it out, the degree would equal the sum of the multiplicities, which is 4. Okay, next thing, let's graph it. And this is just an approximate graph based on the zeros, and I think we can find the y-intercept also. So anyhow, we're going to have a 0 at 0. We're going to have one at negative 2. And we're going to have one at 3. And by the way, our y-intercept, let's see, if we were to set or evaluate f of 0 equals, that's going to be 0. Because that factor is 0, so 0 times anything is 0. Now, the next issue is the right-hand behavior is positive because the leading, the coefficient here is positive. So, and we're going to go through 3, 0. We're going to pass through there because the exponent on that factor is odd. So there's our right-hand behavior going positive. Now we're going to go through x equals 0 and because the exponent on that factor is odd. But when it comes to what's going on at -0, we're going to bounce. And the reason we're going to bounce is off that the x-axis is because the exponent on this factor is even. And we're done. We've got it graphed. We've got multiplicities, zeros, and degrees. Okay, we have one more graph to do. And we know what the graph of f of x equals x cubed looks like. Here it is. And now we're going to graph g of x. And so we've got a horizontal translation. We're going to go 2 units to the left because what value of x will take this to 0? -2. And we're going to have a vertical translation of 1 unit up. So here we go. And well, we know the origin's at 0, 0. Let's do a transformation of that origin. So let's see, the 0 here of this expression is -2, so we'll move that origin over 2 units to the left, and then this says go up 1, so we'll move it up 1. And now our vertex is at -2, 1. Next thing, we need to find the y-intercept. So we've got to evaluate g of 0. And g of 0, if you replace x with 0, you'll have 2 cubed, which is 8 plus 1 is 9. Also, now we have to find the x-intercept, so we'll set g of x equal to 0. That is, we'll set x plus 2 cubed plus 1 equal to 0, or x plus 2 cubed equals -1, or x plus 2, then taking the cube root of both, the cube root of -1 is -1. Finally, solving for x, we'll subtract 2 from both sides, and we get x equals -3. So let's graph it. So anyhow, we have a y-intercept here at 0, 9. And now we'll go down like this, and there's our x-intercept at -3, 0. And we've labeled them both, and we're done.